Okay, if you watch the video, so we went through it, and first thing, just to go over, we spent a lot of time on it, of course. So I spent a lot of time preparing this, actually. I saw the problem on the internet, and again, if you want to watch this video, you can. You also spent time on it. Of course, when these people present this stuff, you should be aware that they do the problem before they present it. And that's true of all problems that you're seeing done on the internet, that the people look at these problems first, then they do the problem. On a video, all right? So anyway, we went through it step by step. I mean, certainly spent time with talking through it so that you're familiar with. You realize it takes time to get through it. Second phase of the partial fraction was tough to get through. We got through that. Looking for recognizable parts. I'll be honest, this is the worst thing for me, by the way, looking for the recognizable parts, right? But we eventually found them, and it took time. It took a lot of effort on my part. And then the integrations, once I found the recognizable part, the integrations were kind of easy to do, but it still took me time to get through it. Right? And we pulled it all together. Really didn't take much time there, less and less time over time. But then I want to point out that, it's remarkable how long it takes me to do something when a machine would do this in a matter of seconds, which really tells me the machine was programmed by someone who really had a good understanding of the mechanics of what I just did. Right? They had a really good understanding of it, and they were able to code it. The machine certainly goes through it quite rapidly, whereas a human goes through it quite slowly. So what I want to do is, let me just get my fonts a little bigger so it looks a little bit more reasonable. And look, whoops, sorry about that. So let me clear. All right, and I'm going to start to type some of this stuff in. And what I want to type in is, I just want to type in how to integrate. So let me reset. I'm going to define a variable. This is just good practice, by the way. You don't have to do it, but it's good practice to get in defining variables before you use them. I'm going to define the function f of x. And what's f of x? F of x is 1 divided by, let's see, x to the 6th power plus 1. It's pretty simple. It's a simple looking function. I'm not going to do partial fractions on it. What I'm going to do is integrate it. All right, integrate. And we're going to integrate f of x with respect to x, and I'll hit return, like 1, 2, 3, return. What is it doing now? Sage's, oh, it did it. Look at that, really quick too. I want to put, I just returned it to me. All right. Now, someone says, does it return the same thing? It returns the same thing. It really does. Be aware that log in most computer algebra system means log base e, and that's true in higher level mathematics. Log does mean log base e. I also mentioned in my notes that I could easily take this and typeset it. All right, what am I doing there? LaTeX underscore. That gives me the output of the prior input return, and what does it do? Returns the LaTeX code to me. So basically, you just copy paste this into your LaTeX document, and that's it. What's the point here? It's kind of frightening. It really is frightening how quick that machine can do the problem, whereas it took me a very long time doing it. And compare it to traveling cross country, how quick it is to take a plane, roughly 6 hours, by the way, and how slow it would be for me to walk across the country. I do benefit more by walking, certainly, than flying. It's certainly more enjoyable to walk as well. You be the judge, though. Be aware of this, though. Machines are quite good at doing thuggish work like I just did through all those sessions over there. It knows what to do and how to do it. It really does. And that's an impressive thing you should be aware of. Thank you.